Hello students, I am Professor Dr. Adarsh Kumar. Today I bring you the next learning episode in BSc Forensic Science of an important unit of paper Forensic Medicine, that is Post-mortem interval part 1. Introduction to Post-mortem interval. Post-mortem interval, also called as time since death, is the time that has elapsed between death of a person and when he is being examined. The changes that take place in body after death are helpful in estimation of the approximate time since death. Estimation of post-mortem interval, that is PMI, is important on following reasons, that is to know when the crime is committed, allow the legal system to deal more efficiently with the available information, to confirm or disapprove LIB, and to enable to exclude suspects or to cross check suspects' statement. The sign of death can be divided into 3 stages which appear in following order, that is the immediate changes, early changes and late changes or the late signs. The immediate signs, as we have covered in the previous episode on thanatology, is somatic death. So, when somatic death occurs, the immediate signs are there. What are those? Insensitivity and loss of voluntary power, cessation of respiration and cessation of circulation. The early changes, they occur up to 24 hours, synonymous with this cellular death. There occurs pallor and loss of elasticity of skin, changes in the eye, changes in the gastrointestinal tract, mainly stomach, then biochemical changes in the blood, then algor mortis, that is the cooling of the body, and then postmortem lividity, also called as hypostasis, postmortem staining or livor mortis, and then rigor mortis. So, these are the changes which occur up to 24 hours. Then beyond 24 hours, we call them as late changes, that are the decomposition. These include putrefaction, adipocere and mummification, that is the altered process of decomposition, and then entomology of the cadaver, that is with the help of forensic entomology. Let us now discuss the immediate changes in little bit detail. Immediate changes or immediate signs, they are insensibility and loss of movements. It is the earliest sign of death, but precautions need be taken to avoid error. These are found in cases of vagal inhibitions, epilepsy, electrocution, narcosis and prolonged fainting attack. Then there is cessation of respiration. There must be complete cessation or stoppage of respiration, which is diagnosed by putting a stethoscope over upper portion of lungs and larynx, where the faintest breath sounds can be heard. The complete stoppage of respiration for more than 5 minutes usually causes death. It may also occur as a pure voluntary act, Cheyne-Stokes breathing, drowning and newborn infants. Then there is cessation of circulation. Usually the stoppage of heartbeat for more than 5 minutes is irreversible and is accepted as an evidence of death. These were the immediate signs of death. So, let us now look the modules which we will be covering today. Module 1 will cover the early changes. Module 2 will cover the algor mortis, that is the cooling of the body. Module 3 will cover the postmortem lividity, postmortem staining, hypostasis or livor mortis, all these are synonyms, and module 4 will be the conclusion. Module 1, early changes. Earliest changes in the skin. Skin becomes pale and white and loses the elasticity. The lips will appear as dark red to black, dry and hard due to drying. Then there are changes in the eyes, a lot many, we will study in much detail. There is loss of corneal reflex, also found in all deep insensibility conditions like epilepsy, narcotic poisoning and general anesthesia. Hence, this is not a reliable sign of death. Then there occurs opacity of the arnia. The opacity is due to drying and the same is delayed for about 2 hours if the eyelids are closed after death. If the eyelids remain open for few hours after death, a film of cell debris and mucus forms 2 yellow colored triangles on the sclera at each side of the iris, with the base towards the margin of the cornea and apex towards the medial or lateral canthus of the eye, which then becomes brown and afterwards black, is called as tachy noir sclerotique within 3 to 4 hours of death, provided the eyes remain open. After that, the dust settles and the surface becomes wrinkled, that which is an artifact. Then there occurs flaccidity of the eyeball. Another change in the eye is the flaccidity of the eyeball. Within minutes, the eyes look sunken and get softer due to reduction of intraocular tension. During life, this intraocular tension usually varies between 14 to 25 centimeters of water. Soon after death, the intraocular pressure is less than 12 centimeters. Within half an hour, it reduces to 3 and becomes 0 at the end of 2 hours. If we see the pupils, due to relaxation of the muscles of the iris, the pupils are slightly dilated soon after death. Later, with the onset of rigor mortis of the constrictor group of muscles and also due to evaporation of the fluids, they become constricted. If we see the retinal vessels, there occurs fragmentation or segmentation, also called as shunting of the blood column. This is labeled as Kevorkian sign in the retinal vessels, which appear within minutes after death and persists for about an hour. Though it occurs all over the body due to loss of blood pressure, but is best appreciated at the retina with the help of ophthalmoscope. The retina is pale for the first 2 hours, and about 6 hours the disc outline becomes hazy, and by 7 to 10 hours it becomes blurred. Then there are certain chemical changes in the eyes. The potassium concentration of vitreous humor at the time of death is 5 to 8 millimoles per liter. The rise of potassium concentration per hour is 0.17 to 0.238 millimoles per hour. This is mainly due to electrolyte imbalance at the time of death. The variation in between the two eyes may be up to 10%. The relationship between potassium concentration and time since death depends on the degree and rapidity of the decomposition. The slope is 0.2 millimoles per hour. Madia and Hanse proposed the following formula, that is, the postmortem interval is 5.26 into potassium concentration minus 30.9. There is a linear relationship between vitreous potassium concentration and time elapsed after death up to 120 hours. This rise is mainly due to the diffusion from retina into the center of the globe. The temperature, urea retention also affect the range. There is a linear rise of hypoxanthine up to 120 hours, which begins immediately after death. There is a correlation between vitreous hypoxanthine and potassium values. The 95% confidence limits are plus minus 32 hours. The chlorides, they decrease at less than 1 millimole per hour and sodium by about 0.9 millimole per hour. Then urea exceeding 150 millimole per hour indicates uremia. The vitreous glucose usually falls after death and can reach 0 within few hours. The vitreous glucose of more than 11.1 millimole per hour indicates diabetes, and less than 1.4 millimole per hour indicates hypoglycemia. Then let us see the changes in the gastrointestinal tract. The amount of stomach contents and the extent of their digestion may be helpful to estimate the time since death if the approximate time of the last meal taken is known. The state of transport of digestion and transport of the food from the stomach to the duodenum is variable and depends on several factors such as anatomical, physiological, pathological, psychological, etc. These mainly depend on total quantity of the food taken, additional snacks taken, ratio of solid to liquid meals, then carbohydrate and fat contents, and there is of course marked variation between the individuals, variations in the same individual from day to day, dramatic variations due to psychogenic and endocrine factors. The stomach usually starts to empty within 10 minutes after the first mouthful have entered. The bulk of the meal leaves the stomach within 2 hours. A light meal usually leaves the stomach within 1 to 2 hours after being consumed. A medium sized meal takes around 3 to 4 hours and a heavy meal requires 5 to 8 hours. A carbohydrate meal leaves the stomach rapidly than the protein meal. Fluids and semi-fluids leave the stomach very rapidly. within 2 hours after being swallowed. Head injury, mental shock, physical or emotional stress may completely inhibit the secretion of the gastric juice and motility of the stomach, and undigested food may remain even till 24 hours. Also, digestion is delayed during sleep or in coma. The head of the meal reaches the hepatic flexure in about 6 hours, the splenic flexure of the colon in about 9 to 12 hours, and pelvic colon in 12 to 18 hours. If the stomach is full having undigested food, it can be opined that probable time of death is within 2 to 4 hours of eating the last meal. Then let us see the next change in the biochemical changes in various body fluids. We will take one by one. Cerebrospinal fluid, CSF. The amount of potassium in CSF increases at a constant rate in relation to the temperature of the body during the first 20 hours. In blood, if we see the changes, there occurs gradual increase in the lactic acid level. The value increases about 50 times in 12 to 24 hours, with the steepest increase occurring in first 6 to 8 hours. Amino acid nitrogen is less than 14 milligram per deciliter up to 10 hours, but rises to 30 milligram per deciliter by 48 hours. Acid phosphatase level increases 20 times by 48 hours. Amylase levels increases 3 to 4 times on second day. The AST4 and lactate dehydrogenase increases linearly over the first 60 hours. The sodium levels, however, fall by 0.9 milliequivalent per liter per hour. Organic phosphorus level in serum reach 20 milliequivalent per liter at 18 hours after death. Then another fluid, synovial fluid, if we see, there is linear rise of potassium which increases more than double within first 2 days. If we see the muscle enzymes, the myofibrillar protease activity increases linearly and creatine phosphokinase decreases linearly after death. However, all the biochemical changes are temperature dependent and apply to cold and temperate climates. They have limited practical application. It must be kept in mind that exact time of death cannot be fixed by any method, but only an approximate range of time of death can be given, because there are considerable biological variations in individual cases. In module 2, we will cover the algor mortis, that is the cooling of the body. During life, a constant balance is maintained between heat production and heat loss. After death, heat production is lost and therefore, the body starts cooling. The post-mortem heat loss is mainly by conduction, convection and radiation. Measurement of the rate of cooling helps in estimating the time since death. When the rate of cooling is plotted on a graph, the pattern of the curve assumes a sigmoid shape, which you can see on your screen. The body surface starts losing heat rapidly, but the core body temperature does not alter until a gradient is established between the core body temperature and the surface. As there is no significant change in the core body temperature for some times, which may be up to 2 to 3 hours after death, an initial plateau is seen. Once the gradient is established between the core body temperature and the surface, the rate of cooling is approximately proportional to the difference in temperature between the body and the surface. The linear rate of cooling is between 0.4 to 0.6 degrees centigrade per hour for the next 12 to 16 hours. Then it gradually becomes slower. When the temperature is within 4 degrees of the environment, rate of cooling is very slow. This is in accordance with Newton's law of cooling, which means after initial plateau, the curve dips down progressively before it becomes nearly flat at the bottom. The preferred site for measuring the inner core body temperature is either rectum or the abdominal cavity. A chemical thermometer with graduations from 0 degrees to 50 degrees Celsius is introduced deep inside the rectum up to 10 centimeters. Alternatively, thermometer can also be kept in contact with the undersurface of the liver through a slit made in the anterior wall in the right hypochondrium. At the same time, the environmental temperature is also measured. After taking two readings, the time since death is then calculated by following formula, that is normal body temperature minus rectal body temperature divided by rate of fall of temperature per hour. This gives the time since death, and roughly we can say there is fall of say 0.5 to 0.6 degrees per hour. However, following variables should be kept in mind. What are these? The body temperature at the time of death is presumed to be normal. In the contrary, in some cases there may be slight rise in the temperature of the body after death. This is known as postmortem caloricity, which can be seen in bodies which at the time of death had suffered violent muscular contractions, that is violent asphyxial deaths such as strangulation, septicemic deaths, strychnine poisoning, spontaneous hemorrhage. Then if the environmental temperature is extremely cold, the whole process of cooling is hastened, while in hot climates the process may get delayed or the body may not get cold at all. Obesity lessens the heat loss as fat is a bad conductor of heat. Ratio between the body surface area and the body mass shows that children and old people cool more rapidly. The rate of cooling is slower when the body is clothed, as cloths are bad conductors of the heat. Module 3 will cover the postmortem lividity, also called as postmortem staining, hypostasis as well as livor mortis. All these are synonyms. Postmortem hypostasis is the bluish purple or purplish red discoloration due to deoxyhemoglobin which appears under the skin in the most superficial layers of the dermis over the dependent parts of the body after death due to capillovenous distension. It is also called as, I already told you, livor mortis, postmortem lividity, postmortem staining, cadaveric lividity, sigillations, vibices. Now, let us see the mechanism how this postmortem lividity develops. It is produced by the stoppage of circulation leading to the stagnation of blood in the blood vessels due to its tendency to gravitate. The blood tends to accumulate in the toneless capillaries and venules of the dependent parts of the body, and these filling of the vessels produce bluish purple color to the adjacent skin. The portion of the body, especially the upper one which is drained of blood, are pale in color. The intensity of the color depends upon the amount of reduced hemoglobin present in the blood. In case of large amount of reduced hemoglobin before death, the blood has deep purplish red color. Now, we see the development, how the postmortem lividity develops. The postmortem lividity begins shortly after death, but may not be visible for about half to 1 hour after death in normal individuals and about 1 to 4 hours after death in anemic persons. Dull red patches of 1 to 2 centimeter diameter appear in 20 to 30 minutes to 2 hours, which deepen, increase in intensity and become confluent in 1 to 4 hours. In very early stages, these patches may be mistaken for bruise, and in case of any doubt, a portion of it should be removed for microscopic examination. The areas then enlarge and combine to produce extensive discoloration. When lividity develops, if the end of the finger is firmly pressed against the skin and held for a second or two, the lividity on that part will disappear and the skin will be pale or white. When the pressure is released, the lividity will reappear. In case of fixation of lividity, no change in color will be seen. Hypostasis becomes fixed when the blood leaks into the surrounding soft tissues due to hemolysis and breakdown of the blood vessels. This phenomena usually occurs in 6 to 12 hours or more. Shifting of the lividity. If the body is moved within few hours after death, the patches of lividity will disappear and new ones will form on dependent parts which are called secondary lividity. A lividity of lighter degree remains in the original area due to staining of the tissues by hemolysis, that is complete shifting. The whole process may take few minutes to up to 1 hour. In incomplete shifting, after turning the body over, lividity appears slightly in the downward facing parts. A non-displacement of lividity is due to hemoconcentration by loss of fluid which penetrates the wall of those vessels related to hydrostatic pressure. Now, we see the distribution of postmortem hypostasis. Depending upon the position of the body and the relevant dependent part in a body lying in a supine position, the lividity first appears in the neck and then spreads over the entire back, extending up to the flanks and sides of the neck, with the exception of the parts directly pressed on, for example, occipital scalp, shoulder blades, buttocks, posterior aspect of thighs, calves and heels, which are touching the surface. If any object or wearing apparel puts pressure and prevents the capillaries for filling up, like collar band, waistband, the belts, wrinkles in the cloths, and such areas remain free from color and are seen as strips for bands, this is called as YBCs. If the body is lying in prone position, lividity appears in the loose connective tissue in front, the color is intense and tardive spots are common. In death due to hanging, lividity is seen on the hands, feet and lower part of the face above the ligature. In drowning, where the body usually floats with the back facing up and the limbs hanging down, the lividity is seen over the limbs, abdomen and the face. If the body has been lying on one side, then lividity will settle on that side. It should be kept in mind that postmortem lividity disappears with the onset of putrefaction. Postmortem lividity cannot be appreciated in a dark individual. Postmortem lividity also cannot be appreciated in a fair skinned person if they have blood profusely or severely anemic. Postmortem lividity may not develop if the body is constantly tossed and turned as in fast flowing rivers. Hypostasis also occurs in the dependent parts of internal organs like in posterior portions of cerebrum and cerebellum, dorsal portions of lungs, posterior portion of stomach, dorsal portion of liver, etc., when the body is in supine position. Then let us see the color changes in the postmortem lividity apart from the normal discoloration. Certain poisonings impart a specific coloration to the postmortem staining, like carbon monoxide poisoning gives cherry red color, hydrocyanic acid poisoning gives bright red color. The nitrates, potassium chlorate, potassium bicarbonate, nitrobenzene, acetanilide, bromates and aniline, these are all agents causing methemoglobinemia. They impart chocolate or copper brown color of postmortem staining. The phosphorus poisoning imparts dark brown or yellow color of postmortem staining. The hydrogen sulfide poisoning gives bluish green appearance of the postmortem lividity. Now, let us see the medico legal importance of postmortem lividity apart from time since death. It is a sign of death. It helps in estimating the time since death, but this may be unreliable due to the various factors I had explained. It also indicates the posture of the body at the time of death. It indicates shifting of the body after death from one position to the other. The cause of death can also be detected sometimes from the color of the postmortem staining. To conclude, I would say that estimation of postmortem interval is one of the most important aim of postmortem examination in solving various aspects of crime and related issues. The immediate signs of death are loss of respiration, circulation and brain activity, followed by changes in eyes after death. The early signs of death include cooling of dead body, postmortem staining and rigor mortis, which occur up to 24 hours after death. The postmortem staining imparts different colorations in various poisonings and also tells about the position of the body. With the help of rigor mortis, we can have a rough idea about time since death by calculating a fall of 0.6 degrees per hour. Dear students, with this module of conclusion, our chapter comes to an end. I hope you all have enjoyed this chapter and gained valuable information regarding postmortem interval and how to estimate it with various changes in dead body up to 24 hours, that is immediate and early changes including rigor mortis and rigor mortis, which we covered in this episode, except rigor mortis, which will be dealt in the subsequent learning episode along with the late changes for the sake of convenience, as I told you earlier. Do keep in mind what we discussed today. I will be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Make sure you revise the modules frequently so that you master the topic well and take up the exercises. Thank you for your time today. I will see you in the next lecture. Keep learning, work hard and do revise the chapter. Goodbye.